Hi everyone, Mr. K here. We're going to do some recursion today. Recursion is one of the ways that you can do repetition in programming. We're going to be talking about, of course, Java specifically, but recursion is when simply put, a method calls itself. So what basically happens is you have a method, and inside that method, the method says, okay, run yourself again, and do it again and again and again and again and again. Now obviously we have to stop it at some point, which we'll talk about, but that's basically what recursion is, just the same method happening over and over and over and over and over again. So we're going to come up with a simple example here. We're going to have a method that simply prints out numbers from where we're going to dictate a starting point and we're going to dictate an ending point. So we'll put in the numbers 0 and 2, and it'll print out 0, 1, and 2. We can put in 10 and 15, it'll do 10, 11, 12, 13, 14, 15. So that's the idea here. We're going to call it count, void count. And it's going to take in two ints. We use int I and int n for no real reason. You can use whatever you want. I typically is used for iterations or loops. So you know which iteration you're on. N is just n. I don't know. You can really call it whatever you want. No big deal. So what we want to do is we want to set up our method so that it prints out whatever we're on. I is basically going to be our starting point, and n is where we are going to end. So it's going to print out I. Now the trick is we want this to increase. We want to just don't print out I, we want to print out I and then I plus 1 and then I plus 2, I plus 3, I plus 4. So what we're going to do is we're going to add a little bit of recursion, which basically means we have the method call itself. So I'm having count, I just pointed to the screen with my finger, I'm an idiot. I'm going to have count call itself, and this time we're going to do I plus 1 and then keep the same endpoint, n. And of course in my main I need to start this off somewhere, so we'll call it 0 and 2. Now this is going to break. Those of you who know what you're doing are looking at this like I'm crazy. This is going to break. And let's just run it and see how it breaks. Ugh, that's a lot of red. Lots and lots of red. But it's kind of working. I mean, it's counting up. It's not starting at 0. It's at 4074. Well, that's because it ran out of room. It did print out the initial ones, but it just stopped. Now here's where the error starts. Stack overflow error. There's this thing in, at least in Java programming, there's a thing called stack memory. And what the stack is, it basically works on the principle of it takes methods that are running and puts them into the stack. Kind of like you want to think of a tower of blocks. So it puts a method on and then puts another method on top, method on top, method on top, method on top. And as methods end, they get removed from the stack. Well, the problem we have right here is, well, our methods are never ending. So count starts, it prints something, and then it calls count again. But if you look at this first instance of count, we never actually get to the end. We call another one before we finish. And then we call, and then it goes through again. It calls another one before we finish, another and another and another. And none of them actually finish. So what ends up happening is the computer just says, that's it, it's enough, we can't take it anymore. Stack overflow error, bail out. So it's definitely a downside to recursion. You just have to watch and make sure you don't have anything that gets too big. But in our case, we don't have it set up so it ever ends. So we need to throw in a conditional. So if, we need a big if in here to say, okay, only do this under certain conditions, because if it's not those certain conditions, we want it to stop. So the question is, when do we want this to stop? Well, we want it to stop when it hits n. So if we put in when I is less than or equal to n, this will only run while I is less than n. That's our endpoint. So in this case, 0 is less than or equal to 2, 1 is less than or equal to 2, and 2 is less than or equal to 2. If I've done this right and haven't screwed anything up, this time it should print out 0, 1, and 2. There we go. So the first time through, count, 0 is less than n, prints out the 0, and then it runs it again, this time with the I slightly increased, same endpoint, and then it goes through again, printing out the 1, and then it's 1 plus 1, and then it prints out the 2. So, and it works for any of them, so I think I said to do 10 and 15. There's 10 and 15. 10, 11, 12, 13, 14, 15. So same deal. Prints out the I, increases it, and runs it again. And then it will keep doing that until it hits that endpoint. Now you can still get a Stack Overflow error here if your numbers are too big. So I would do like 60,000. Oh. I hope that loudspeaker announcement didn't come through on the microphone. If I do like 60,000, I still have the same problem I had before, where it's just too many methods on top of itself. There is a limit to how much you can do. So recursion, depending on what you're doing, may or may not be the best tool. We're going to get into other looping methods a little bit later on, but for what we're doing now, recursion is going to be perfect. Okay, so just in this case, let's get rid of this 60,000. Print I, increase it by 1, and run the whole thing all over again. And as soon as we hit our ceiling, that means that this if statement's not going to run anymore, and then all the methods end. They hit their endpoint, and program clears, and you are good. So here we go, 10 to 60. That's recursion. Bye.